So this question asks us to determine domain and interval notation for each of these functions. So let's take a look at f of x equals 2x minus 6 over x squared minus 5x plus 6. Now, what do we think about that? We know the denominator at the bottom cannot be 0. But to do some analysis here, I should factor. In the top, I can factor out a 2. I have 2 times x minus 3. On the bottom, what do I get? Well, I have x squared minus 5x plus 6. I like to factor this way. X squared is here, 6 is here, minus 5x. X times x minus 3 times minus 2, minus 3x minus 2x. So I get x minus 3x minus 2. Now remember, the bottom cannot be 0. You cannot divide by 0. So x minus 3 cannot be 0. You're saying it divides out. You're right, it does divide out, but not here. If I plug 3 in here, the bottom becomes 0. That is not acceptable. So x minus 3 cannot be 0. X minus 2 cannot be 0. X cannot be 3. X cannot be 2. So I remove those two numbers from my number line. 2 is removed. 3 is removed. But everything else is in the domain. We have this piece, we have this piece, we have this piece. So we get negative infinity to 2, union 2 to 3, union 3 to plus infinity. Those are the allowable inputs. Those are the allowable inputs that we would have for our graph, for our function. Okay, what do we have next? We have the square root of x plus 7. G of x is the square root of x plus 7. Okay. What do we have to remember about that? Well, we're working with real valued functions, so the thing under the square root cannot be negative. So x plus 7 must be greater than or equal to 0. So x has got to be greater than or equal to negative 7. So negative 7 is here. Greater than or equal to makes this a solid dot, and we're going to shade it that way. So in interval notation, that would give me square bracket negative 7 to plus infinity. Let's take a look at a graph of that. Let's go to Desmos and look at a graph. If I can, I've got to load Desmos first. Now I can go there. So we'll take a look at g of x as the square root of x plus 7. And you will notice the earliest input you see is negative 7. X values beyond negative 7, yes. There's negative 6, there's negative 5, negative 4.5, etc., but nothing to the left of negative 7. So that reinforces what we did here on the paper. What do we have next? This thing. What is my domain? We're assuming the graphs continue infinitely beyond the frame. So we assume there's arrows here heading up and there's arrows here. And the reality is this is all real numbers. So we would say about this function that looks like a kind of function we will study this semester, heading that way, heading that way. The domain is all reals, which we will write in an interval notation as minus infinity to plus infinity. Okay, what do we have next? We have this thing. Again, we're assuming that it goes on beyond the frame. But the lowest x value I see is 2, and it's a solid dot, which will make that a square bracket. So I'm going to have a square bracket at 2, and how far does it go? Does it eventually get to 6, 7, and 8? Yes, because we're assuming there's arrows here going beyond that. So from all the way from 2 to infinity is what we're dealing with there. So 2 works. We had a solid dot there and everywhere to infinity beyond. Beyond 2. So we're going to take the square bracket. 2 comma plus infinity would be the domain for that function. And that's all of them.